Maximize motion.
This is our movie of engine measurements. This is the first angle of how to check depth warpage. This is the second angle. This is the third angle.
In this procedure, you use a flat edge, not a ruler. You use feeler gauges to the center of the block in this procedure.
Surface area must be cleaned before doing this procedure. After cleaning your surface, now you can apply your dial gauge on the sleeve and then set your dial gauge to 0. Slowly run your dial gauge to the sleeve to the liner and record your results.
In this procedure, you use an internal micrometer. The internal micrometer has spacings to suit the bore size. When doing measurements, you must encounter those spacings. There are 3 points of measurement: bottom of the bore, center of the bore, top of the bore. You turn it out, you take into account of your spacings, and you record your readings.
You set your calipers on the crank, lock it in, and get your recordings. To get the general taper, you use a micrometer meter. You set, you record, you turn 90 degrees, and get your results.
To get the outer roundness, you set your micrometer to the edge. You must ratchet it tight and get your readings. You turn 90 degrees and you do this procedure again.
The correct way of using a micrometer is how it is shown on the picture there. Before you start any procedure, make sure you clean your micrometer using a piece of paper. Ratchet it onto the piece of paper, slowly pull it back and set it to 0. If it doesn't set to 0, do this again. In this procedure, you will have to set your dial gauge to 0 and your inner gauge to 5 thou. After you've set your dial gauge on the crankshaft, using V blocks, you slowly turn the crankshaft around 180 degrees and get your results. And you follow this procedure on the opposite 180 degrees.
You use vernier calipers to measure the lobe surface. Then you use vernier calipers to measure the lift surface. You deduct your lift from your lobe surface to give you your height ratings.
You use a hole gauge, wind it out to the face of the bearing, lock it in and pull it out. After you pull it out, use a micrometer to measure it up, ratchet it onto both sides of it, and that will be a result. You use a micrometer to check 3 positions: top, middle and bottom, for the piston diameter and ovality. This is the center measurement.
The correct way to set gap spacing is 120 degrees from each individual ring from top to bottom, and not in line with the gudgeon pin. You use a feeler gauge to check the piston ring end gap. You must compress the ring and use a feeler gauge to get a correct reading.
To get the depth of your ring groove, you use a vernier caliper. You open it up and lock it in. After locking it in, pull it out and that will give you your reading.
Once you have your dial gauge set up on a surface that is not moving, like the block on the engine, you zero it out while touching it on your crankshaft. You go to the other end, you pry it, and you record how much movement you have in your bearings. To check your free spread, you sit your cup in your conrod housing. Your cup has to be a bigger diameter than the housing of your conrod to make sure it has free spread. If you're carrying out a rebuild to an engine, you would normally replace these if you're replacing everything.
To make sure you've got crush, make sure your cup is overlapping the edge of your conrod. To get side clearance, put your feeler gauge in between the gear and the housing of the pump. To get gear and clearance, you use a flat edge across your gears and your housing. Then use a feeler gauge on your housing and that will give you a result.
You check your backlash by putting feeler gauges in between your 2 gears. When you have the most open area between the 2 gears, you use your feeler gauge to get the width and your measurements.
First of all, you must have your engine upside down for this procedure to work properly. Then put your plastic gauge on top of the crank and then bolt down your bearing housing.
Hang on.
After bolting down your bearing housing, you must torque it up. After torquing it up, you must undo it. This will leave the marking of your plastic gauge.
Now you measure the plastic gauge with the tool given with the plastic gauge. You compare to manufacturer's specs to see if it's within specs. You use a flat edge to check the warpage on the face of your flywheel. This check is done with a visual inspection. You use a straight edge on your lug to see if it's bent. You turn 90 degrees and to see if that is also bent. You set your dial gauge up onto the flywheel. You zero it out. You rotate the flywheel slowly to see how much movement you have. This is for radial run out on the flywheel. For the axle run out on your flywheel, you set up your dial gauge on the face of the flywheel and rotate to see how much movement there is. You turn your multimeter onto volts. You set your positive lead from volts to ohms to your positive side of the battery, and your negative lead to the negative side of the battery back to the column. Record what you can see.
This is the Tech 2. First plug it in,
You go into your menu screen and into diagnostics.
into your car's year's model. Ours is a VY series. Go into your chassis. Then go into your ABS/ETC. Turn your ignition on. This will give you your chassis part number.
I hope you enjoyed the movie.
And thanks for watching.